I've created a hook for the activity, but I'm not sure if it actually works because I'm not tested it. So I'm not giving any guarantees. But let's see if this works.
Nothing yet.
I mean, yes, we are live on YouTube.
Okay, I don't see the stream here yet.
Yeah, but there's a lag of 10 seconds and it's freaking me out. Let me mute this YouTube thing.
Oh, it started, is it?
Yeah, it has started.
It's not showing on the camp link on the page.
It's showing for me. Try refreshing.
I did a couple of times.
Oh, but Yak PDP did not post any links, which is very sad. Sad.
Let me open in a different browser, maybe.
I think just try refreshing once more.
Boomer.
Yeah, I still don't see it. I opened in a different browser too.
So it's officially 5:50. Welcome to the Camp for Advanced Mathematical Preparation, also known as CAMP. It's official. We are officially starting. Oh wait, we only have 20 participants, which out of 50, which is very sad. No way. 80 people are online on Discord. So I guess I'll take that.
Yeah.
Can this check on YouTube? No. Only our faces can be seen on YouTube.
I don't think it's publicly visible, maybe.
I can see it.
Is that so?
What is the YouTube channel?
Like on camp account, I am able to see it, but I am not able to see it on.
Oh, really?
What is the channel name?
Maybe try refreshing.
Oh, wait.
I'll send the link to the video.
Okay. Yeah, got it.
I'm watching now. Wait. Let me just. No, it's public, right?
Okay, here then let me try. Like the link works, link shows, but on the page it's not showing.
Oh, it's private. Okay.
Like it's working for me. It is working quite good.
Okay, weird then. Just me then.
No, it's not unlisted. It's public, right? Like,
Okay, weird then. Then just me.
okay, but yeah. So first of all, everyone turn on your cameras. We should be taking up the camp photograph. I think that's how this is supposed to work.
Somebody just said no, please no.
Also, I mean, like you can watch it if you don't have a webcam, you don't want to turn it on. It's oh wait.
Not prepared for this.
Not prepared for this.
Angel is saying something while being muted.
Sorry, I'm just saying, like, switch on your camera.
Atman, I don't see either. Like,
Yeah, exactly.
yes. Sometimes my camera doesn't work either for some reason. I can't always explain.
Technical training these kids need.
Okay, so let's discuss about bandwidth issues, of course. Yeah, so let's discuss about what the camp is gonna be about. So you may or may not have seen the schedule, which is conveniently posted in the channel called schedule, where you expect it to be. So first things first, the time slots are only approximate and can be off by up to half an hour. Secondly, some people are going to be 60-minute lectures and some people are going to be 75-minute lectures. And that is fine, like you don't have any activities overlapping with lectures. So all lectures have a gap at least one time slot between any other lectures.
Ritam, your voice is cutting a lot.
I don't think I can. Okay, yeah, okay, so try opening the schedule. You'll see there are 2 lectures and 1 problem session every day, like every single day, except like today where we will discuss the application problems instead of having a normal problem solving session. So we will be discussing the application problems right afterwards. So Rohan will be taking that class. And we'll have 2 every day, and usually you'll have a break between the 2 classes. Or so the breaks are listed as group solving. So for the group solving, you can like work on any homework you have in the Discord channels. So there are 3 group solving channels in Discord. You can like and solve problems with others. You are encouraged to work together on homework problems unless instructed otherwise. Secondly, there are going to be a bunch of friends at this camp. I think Rohan knows better about them. I don't know. I've been sleeping most of yesterday, or rather most of today. Rohan?
So activities you said, right?
Yeah, activities. Like
Yeah. Okay.
Hanabi or whatnot.
Yeah. Okay. So one thing I was doing was mathematical match or something on Sunday, in which you'll just divide into teams. I'll use a random team generator or something, and then you attempt problems, which I'll give. Timing and all is given in the general. Next Sunday, 8th August. Ritam, you're muted. You're muted if you're saying anything.
Yeah, no, I wasn't saying anything. I was just laughing at front.
Okay. Then Saturday we have some puzzle thing. Okay, where you'll again be in teams, and I'll send a couple of. Okay, I may be switching the days though. It's in the chat. You can check. So you will be given puzzles or easy problems, computational maybe, and you solve one, you get the next one. Initially, you start with 3. The team that solves the most wins. I think I added some weird thing into it, some song guessing thing. That's up to you if you want to do that. I made that up on the spot. Don't think too much about it. Third is the friending thing, where you'll be paired up and you'll just talk to other people. Other than that, there are some game nights, and tomorrow and day after, I think Hanabi is being conducted. Otherwise, people are playing chess and other games in the games channel all the time. I think that's it.
I was going to say something, but I just forgot what I was going to say. So I'll have to think about what I was going to be saying. Right. So the schedules are slightly approximate. Don't worry too much about it. So, like, not really, like, most of them are example. Let's just say some of them could be slightly late. Yeah, never mind, don't think.
Yeah, so like you can just say that your class timings are changing.
Also, can you really not see the YouTube video? Like, that would be slightly problematic because we were planning to like live stream all of them. Or maybe we just record and upload it later or something. I don't know.
Uploading later works well enough if it's not visible. But like the stream is there. I don't know why it's not visible, but if you use the link, it works.
Yes, we are planning to upload everything on YouTube. We will also share the notes on Google Drive. So
Yeah, also it's
there's
visible.
this. It's not unlisted. Like I made it public. Like on the,
Yeah, it's visible now. Earlier, maybe it's just a delay in showing there on the page from YouTube side or something.
and it seems to be fine. Like there were 9 concurrent viewers at some time. I don't think 9 people even have access to the CAMP account. So
No, it was
that's
searchable
it
and
fine.
all. It was
Yeah, I think
searchable
it should
and all.
be fine.
Yeah.
The other thing is that I to get this Yak PDB hook working so that it can auto post the YouTube links on announcement. So, anything else that we want to discuss before everyone discusses? Yeah, so if you have any specific problems that you want us to discuss during our problem solving session, just post them somewhere. Maybe I should make a separate channel for that. I don't know.
You can just create a problem suggestions channel. If it does not get picked in PSS, they could do otherwise. Like,
Just created a so yeah, we'll try to discuss those in problem solving sessions or someone else could like discuss. But before posting it onto like the problem suggestions channel, I would recommend posting it onto one of the 4 like algebra, combinatorics, geometry, and budget channels, and try to see if it gets resolved before that.
So should the problems we suggest not necessarily be our doubts, right? Like anything.
No, like if you want us to so if you have a problem that you have not solved, like that you have tried and not been able to solve, and you want us to discuss, in that case, you post on the problem suggestions channel for the problem solving sessions. But before you post it on the problem suggestions channel, just post it on one of the main problem discussion channels so that people get a chance to at least discuss or like solve the problem themselves. And the feedback. I think we will be providing feedback forms at the end of every day so that you could give us feedback for our letters. And yeah, make sure to fill out the forms. That would be very helpful. Was there anything else?
also, in general, if you've seen a problem, you shouldn't suggest it to the PSS because these will mostly be very interactive, I think. And everyone should be involved in solving the problem together. So if you solved it before, then you're just watching and it's no fun.
The group solves is basically like a problem solving session, except it's not. So there would be no instructors involved for the group solves, or at least for it. So you will do it by yourselves on Discord. Like it's kind of optional. If you want to discuss any of the homework problems on Discord with others, then you can do one of the post channels.
No seats would be discussed. So
Why did I turn on this live description thing? It's so funny.
Yeah, I know, right? Like, hilarious.
Yeah, I know it hit me. That's what it's. What?
Yes, these titles are these subtitles are just amazing. They are translating very good.
Yeah, so for PSS, actually, for most of the PSS, we expect the staff to curate problems by themselves, like nice problems. For group solves, it's more like discussing homework problems we have to be giving during the lectures, or even just post-lecture discussion. Anyway, so Rohan, do you want to take over and start discussing the application problems now, or should we take a short 5-minute break and come back?
I think a break is fine, and probably a different announcement, I guess, right?
I think this meeting room is fine. Like you can just continue here. And wait, I'll make you host.
Can maybe just make a new announcement so if anyone was not planning to attend
I'll
the
just
open.
post in a number.
I mean, not enough people switched on their videos for the photo shot or whatever.
Yeah, that's the thing.
Yes, courtesy of some institution, we have Zoom unlimited version for now.
Yeah.
Don't do this. Don't worry, other institutions also provide free Zoom.
Oh, I just forgot. I want to thank our sponsors, MMC Fund, for sponsoring this program.
Oh, okay. You have this idea from a long time, or you just got recently?
I mean,
I think the motivation was in
This is
Yeah.
just continuation of last year's unofficial TC, no? So that
Oh, okay.
last year TC was not held, so Atman and Ritam conducted unofficial TC for most of the students, and then we again had a lot of lectures and all.
Oh, okay. So this idea was prevailing for a long time.
Yeah, so this is basically the second version of that.
Okay.
Shaurya was busy this time around. Like,
Yeah, that there go half your lectures.
Yeah, so Short couldn't join, unfortunately. Like I asked him, but he was like, these two babies.
Yeah. Wait, even now, okay, sure. Some,
Even
In the subtitle, it is written these two babies.
what? What? Why? Okay, let me just switch this thing off. Okay. He never.
Rhythm, I got reminded of monsoon math camp when you just said baby. Bad
Yes.
memories.
You are a
Yes.
baby.
Man, why
what
I also-
happened? What happened there?
My JC, he was RSRA. So in every squad meet, he used to call me baby. And for 1 hour, we used to do this thing only. He mostly didn't have any other thing to do. And this was the most entertaining thing for others in our squad meet. And in the ending ceremony, he disclosed this to everyone.
I think you can start now, Rohan.
Okay, let me look for the file. Yeah, okay.
Yeah, I posted it in the chat. The application problem file.
Yeah, that is fine. I meant the solution file that I wrote.
Oh,
Is this visible? Also, people just switch on videos, please. If it's possible. Yeah.
yeah, it's visible.
Yeah, okay. So the first problem, I think a lot of people did. Okay, let me also turn on the subtitles. They're just annoying at this point. Yes, the sources, I do not know the source of P3, but P1 is from some Code Forces contest and P2 is from Momo. Okay, so P1 was you have n distinct points on the plane and prove that you can label them P1, P2, Pn, such that angle pi plus 1, pi plus 2 is less than 90. This was on the easier end of problems, but it was slightly scam. So like even you might miss it. Okay, just give me a second actually. So the idea is simply that since the angle sum of a triangle is 180, and if the side opposite pi plus 1 is not the longest side, then you will not have the angle will be smaller than 90. So what we just do is we pick a random point, take the point farthest from it, then take a point farthest from it, and so on. Now, if we just want to show that the pi plus 2 is not the longest side, but by the definition of pi plus 1, pi plus 1 is longer than pi plus 2. So we're done. That's it to the problem. There's nothing much to it. Is this fine?
Yes, but what details do we need to take care of in the inductive approach?
Okay. Yes, the inductive approach. Let me open a new share for that. Okay. So let's see what all is there. Okay. Can some people did the induction that you have P1, P2, Pn minus 1. You bring a random point. These points work. You have some labeling. You bring in a Pn and you try to place it somewhere. You try to place it here, but it does not work. So you just switch these two. This was the approach said, but the details were not worked out. Like if when I switch, it might still not work. Now if you're saying switch it again, now if you say Pn minus 2 comes here, Pn minus 1 comes here, Pn comes here, and Pn minus 3 is here, and so on. Why should this still work? Like why should this angle work out, or why should this angle be good? If this angle works out, why should this angle be good? Such details were missed. Like
Because if
I
Pn minus
remember.
no, I'm not saying that they're not easy to work out, but they were missed. They were not
I
explained.
didn't miss them.
Okay, can you? Okay, I don't want to go case by case because we had like over
Okay, sure.
40 wrong solutions which miss small details. So I really can't go case by case. Okay, I think subtitles can only be stopped by Rhythm for the mail. Oh,
I have
also
no
you can,
idea how to stop them. Let me just.
okay. For personal transcription, you can stop from the bottom. Just go on your live transcript and press hide subtitles. For the side, for the YouTuber. Okay, I think that's the major detail. People did not work out what exactly happens when the switch. There are multiple cases. There's not just one issue that comes up. And how many switches can you go? And why should the switch work out always? I think Rhythm also would agree that there are small details that a lot of people miss.
Yeah.
No, why won't the induction work? I didn't know.
No, it does work out. But it has to be done carefully.
Oh,
People did not necessarily explain why it does work out.
Yeah, so inducting here is actually pretty tricky. So there's essentially one induction solution that works, and the others would actually most induction solutions actually don't work because you end up moving lines in such a way. Yeah, so it turns out that in most induction solutions, you end up moving moving your selection of line segments in such a way that you break some of the previous angles, and it's sort of unfixable. But there was a solution that worked. I mean, I think there were quite a few induction solutions that you guys submitted that did work, which essentially relied on I think it relied on picking the first J such that, or rather last J. It does not make a difference. So
Yeah,
picking
yeah.
a J such that that I think
This angle works out.
yeah.
P J P and PJ plus 1. Yeah. From either
Yeah,
side.
and if such a J does not exist, you can just put it at the front.
Yeah.
Yeah, so that was the solution that works, but the others typically mess up. As to the algorithmic solution, most algorithmic solutions actually don't seem to work, if I remember.
Yeah, this algorithm is quite close to the intended induction, but it missed a lot of people who did this algorithm missed too many details, I think. Special cases like P and P and minus T and whatever and so on.
Yeah, I mean,
It's hard to work out such details anyway. If you
yeah,
don't-
I think the details I mean, there were a lot of details that were missed in these solutions. In fact, I'm not sure if all of these solutions were even fixable.
Yeah.
But the max length solution is very clean. It's basically a one line.
Yeah. The max length is the main intended solution. I think, but that's more of a person algorithmic thing where you're defining them in a recurrence way. But most people from a maths background just go for induction because that's what they used to, I think.
Oh, yes, yes. Yeah.
Yeah, also I'd just say this was maybe easier as a problem when it came on code forces because you're supposed to be able to find the points. So you like have to go for something greedy. The math thing over here actually greedy works out much easier than induction
Yeah.
because you can choose the points well.
Yeah, yeah.
Okay. On before going to P2, let's discuss P3. I think that's much more interesting. And the solution that we got was also quite amazing. So, okay. There's one thing we'll be assuming, which I'm not going to prove, which Pranjal will discuss later as well. That if there is a sequence, if like we have the normal sequence of primes, right? P1, P2, Pi, and it's just the set of primes. Then for any value, R, any real, what happened? Okay. For any, hello, is there some issue? Okay, there's some integer. So like pk minus kr is always eventually positive, and it stays positive for any r. It's always eventually positive. Is this fine? Is this claim fine? You'll have to just assume this for now, that this sequence of primes grows faster than a linear function. Yes.
Yeah, fine.
Okay. And okay, so the problem does not really care that it's the set of primes. It just cares that the sequence you're talking about grows faster than any linear function. So the solution is basically this. Consider pi minus ki for some constant k, which is at least 3. Now, pi minus ki is eventually positive by our previous claim. And initially it's negative because p1 is 2, right? So initially it's negative and eventually it's positive. So at some point, there must be a minimum. Is this fine? Because there are finitely many values you have to cover, so there's a minimum. Let's say the minimum was hit at some value plk. Now plk minus klk is less than plk plus m minus klk plus m by our assumption that pk minus klk is the minimum value this function takes, like this sequence takes. And again, pk minus klk is less than equal to plk minus m minus klk minus m. Just adding the two, you get the desired result. That 2plk is less than plk plus m plus plk minus m. So plk works. Now the important thing we want to show is that this minima of pi minus ki for different k occurs at infinitely many different values. That's what we want. Now, how do we do that? So what we simply do is, as we are picking k, let's say our, okay, you want to show that you can take arbitrary values. So, okay, how do I write here? Okay, let's see. So now let's say our minimas occurred for L1, L2, and so on till LR. And we are saying, you're saying that these are the only values the minimas can occur at. I argue that let's say PLR is the biggest prime we have considered till now. Yes, I'll put the solution PDF on the server. So let's look at PLR minus 1 and all these values till now, till P2 minus P1. Again, these are finitely many values, so they have a maximum, let's say S. Max is, now just pick K greater than S. Now, since the sequence will keep, okay, let's also add PLR plus 1 minus PLR. Now the sequence is always decreasing in these PLR, in the first PLR term, in the first LR terms. So the minima cannot occur in the first LR terms. So it will have to occur at a larger value, and hence we are done. Is the argument fine? I think the argument might be troublesome, slightly weird to some people. So please tell me if there's an issue. And as we see, this thing works for any function that grows faster than linear functions. In fact, you can do the exact opposite, like reverse the inequalities everywhere to get the reverse result for any function that does not grow as fast as linear functions.
So the sequence Sk we take and we use the lemma for this sequence.
Yes,
Okay.
this sequence is eventually positive, right? So it has a minimum because
Yes.
initially the value is negative. So since there's a minima, we just take the value at which the minima is taken, and that prime works. So we just want to show that for different cases, the minima occurs at different places, like infinitely many different places the minima can occur at.
Oh yeah. So this lemma is well known or not?
Which one? That primes grow faster than linear functions?
Yes.
Yes, it's very well known. Pranjal will in fact be discussing it today.
Oh, okay. Yeah, I didn't know that. But that does not matter because this proof is really good.
Yes. I think it's very smart.
Is it true for polynomial functions also?
Yes. I mean, as long as the function is not linear, it will work. And for polynomials, it's much easier to prove, in fact, because you do not have the randomness.
Lemma. The lemma for prime.
What do you mean polynomial functions then?
Like we are showing greater than linear function. Eventually greater than linear function. So will it be true for polynomial function also? Will prime be eventually greater than polynomial?
No. Just linear functions. It's approximately x log x, as you may know.
And prove like all of this like today at from 8 to 9. So
yeah, Pranjal will be discussing the proof of this, as I said, from 8 to 9. The growth rate is approximately x log x, as I said. So it's faster than linear because log x is faster than constant.
Oh yeah. That does just immediately follows.
Yeah. So Pranjal will be discussing it in much more detail tonight. Just actually raise your hands if the proof is fine by you. If you need time, then you can take time.
Like we prove 2PLK is less than equal to this thing, but then how does it prove that this is less than for every like for every prime number less than that? Basically the condition.
I mean, M is arbitrary, we did not pick M here.
Oh, okay.
We said M is anything less than LK. There also exists proof by some analytical ideas. I've sent the notes of that in this
Oh,
server.
that analytical proof will also be quite good, but it would be very hard.
Yes, and I think, as Pranjal said, it's much more motivated than this. I do not know how he came up with it. He tried to tell me that and I didn't. I'm still very impressed.
Wow. Like analytic methods or not?
I
No,
mean,
there's nothing like, there's no real analysis. It's just I do a lot of motivated things for a lot of time and it ends up working. This proof is just like very clever and avoids all that work. So actually, if you
Oh,
understood this proof, I'd suggest don't even bother going through the other one. It won't help with any motivation.
yeah,
It's just longer and messier. This
yeah,
proof is like really brilliant.
yes, yes.
yeah. Yeah. Okay, not much. I do not have much to add there. Okay. Anybody who has any doubt can please just speak up. Uh, what if then uh, I mean LK equal 1 does not matter because we are just talking about when the minimum is achieved, and then okay, I mean you can just pick so that LK such that LK is greater than 1. We just discussed. Okay, is it clear how we can pick a K such that LK takes arbitrarily large values? Okay, okay. So let's assume that it did not take arbitrarily large values. So LK could take the values, let's say, it can take values only less than n. Now Pn minus Pn minus 1, Pn minus 1 minus Pn minus 2, P2 minus P1 is some set of values, and it must have a maximum.
I think you can make a nice diagram with that
What?
to explain the idea.
I don't quite get what you're saying. Okay, there's a maximum value in Pn minus 1, Pn minus 1, Pn minus 2. Let's say it's R. Okay, can you please not annotate and just speak up? Bhavya. Yeah.
Yeah, so basically, I think I understood it. So let us say we are just plotting it, like we are plotting the n in the x-axis and Pn minus Ri in the y-axis. So what it is saying that it will eventually be always positive. So actually, I need to make a diagram to make it. So basically, there will be a dip and then it will be all positive. So we have to show that the dip can be arbitrarily large.
Uh, Not exactly, because we just want to show that the dip occurs at different places. We do not care about the size of the dip.
Like it achieves a minima here and then becomes positive. So once we have a dip, if we have a dip of this much size, then it will true for this region. So
Yeah,
we
but
can
it
make it
does not.
arbitrarily large.
It does not need to be on the middle. It could be anywhere else.
I mean, it does not even matter what the size of the dip is. We want it to happen at different places, right? We care about which prime. It happens at infinitely many primes we want.
Yes.
We do not care about the size of the dip or how much lesser is it than its neighbor. Anyway, let's say
I
the
don't
map.
exactly mean the size. I mean the length of the disk.
Yeah, that's not a different thing, no. Let's say the maximum value of this set is R. Okay. So now if we just pick our K greater than R, then among P1, P2, Pn, this value just keeps on decreasing. Correct? Is this fine? Because the value was P1 minus R first, then it became, sorry, P1 minus K, then it became P2 minus 2K. But the difference here was P2 minus P1 and the difference here was K.
Yes.
So it decreased and it will keep on decreasing among
Yes.
the
Now understood.
first n values. So the minima does not occur in this set. So the minima occurs outside, so we are done. Is it fine now? Okay, great. Okay, good. Moving on to P2. P2 is a construction-ish problem. So the P2 gave you a structure where you had to be slightly take a leap of faith and just guess what type of function does work. I do not think you can just keep looking at it and just keep working out details and it will force you to be this function. I think you have to take a leap of faith and guess it is this function. At least I think it's necessary. What happened?
What you said, we have to guess the function.
Yes, you get some structure, you look at it, you get some details and you see.
Yeah, I tried to guessing, but I did not like guessed clearly.
It's okay, that's totally fine. So
Like what is you have written f of 11 comma 3 is equal to 4. I did this.
okay.
But
Sorry to interrupt, but there was some
Didn't
network issue, so I just joined now. So like what all things I missed?
We discussed P1 and P3, whosoever this is.
Okay, now we are starting with P2.
Yes.
Yeah, okay.
Yeah, okay. So P2 has some structure. Okay, you have given some structure. You've given f of a plus b comma b is f of ab, when a greater than b. Now the other case you naturally wonder what happens when b greater than a, right? Or so something you want to do is like you want to impose more conditions to make the structure more stringent, and then think maybe does some function satisfy this if I just impose this one more condition. And since you have this already, the natural thing to do is to impose it on the other side as well, right? Like if you increase b by some amount, like f of a comma b is f of a plus b comma b plus, sorry, a comma b plus a. I think that's a fairly natural thing to try. So this someone phrased it as long division algorithm, which I liked actually. Earlier we were going with the standard biased Euclidean algorithm or some other name, but I think someone framed it as long division algorithm, and I like that way of thinking. So the idea is you just perform the long division algorithm with the first number as the dividend and the second as the divisor. So sorry, second as the dividend and the first as the divisor. So 3 comma 11 becomes 2 comma 3. That's one step. then you go 1 comma 2, that's 2 steps, then you go 0 comma 1, that's 3 steps, and that's it took 3 steps, so the value is 3. Similarly, 11 comma 3, you cannot directly do it because 11 is greater than 3, so you have to reverse it. That's 1 step. 3 comma 11 goes to 2 comma 3, 2 steps. 1 comma 2, 3 steps. 1 0 comma 1, 4 steps. That's basically how you define f. Now you just want to verify the properties. I think property 2 and 3 everyone can see follow directly, because you can just reverse engineer the algorithm to go as long as you want and just
Yeah,
add.
so like that number 2019 does not matter now, I guess.
Yes, it's just to give a
Yeah.
low. Now the other part is a plus b comma b and a comma b. Since a is greater than b, in both cases you have to first reverse. That's the 1 step. So b comma a plus b and b comma a. And then when you're dividing by b, the extra b does not matter.
Yeah.
So
Got it.
they'll work out in the equal number of steps. The most important part is the first one. For this, you needed another observation. So as to
Yes,
say,
the distance between these 2 points is smaller than 2.
yes. So the observation you needed here was from P you could subtract R and from S you could subtract Q, and it will still work because both differences you subtracted QR. Like PQ minus QR, the first value becomes, and the second one becomes RS minus QR. So if P is greater than R and QS is greater than Q, then you can just induct down per se, because both of these either take a step or both don't take a step. And if this case is not true, when P is not greater than R, then you can just reverse it, Q comma S, P comma R, and then you can work, and everything is good. The base cases are easy to verify. Is this the only possible function? I do not know if it is. I think this is the only reasonable one to find, and I have not seen a separate construction till now. Neither have I been.
What I did is like I tried. I saw that the set contains only pairs which have this GCD1. So I used like GCD of A and B equals GCD of A n plus B, A plus NB comma B,
Yeah.
and then constructed infinitely many points for which the function gives the same value, but did not continue to finish the problem.
Yes, that is a crucial observation, that if you can find one place where A greater than B and a certain value is found, then you in the second condition would force you to find infinitely many of them.
Yes. And also my difficulty was that when I was doing this third condition, I did not find how to use it. So that is why I did not able to finish.
The main point of the third condition is just that you do not make it a constant function.
Yeah.
So isn't this problem kind of open because we don't know if this is only the solution?
I don't think it you can call it open, since I don't think
Like kind.
anybody bothered enough to try to solve it.
And also the problem is only asking is there exist a function.
Okay, so what was the motivation for taking the number of steps? Okay, the motivation is not directly as this, like as the solution goes. So the motivation is first to try to impose a second condition, because like a plus b comma give b comma b is equal to a comma b gives you some structure but not enough of it. So the idea was a comma b and a comma a plus b should also be equal always. You try to impose that condition, and now you see what happens. Now the only thing we were left with, what if a less than b? And then again you want to work on a structure that you're comfortable with, which is b greater than a, right? So we thought, okay, why not just give away one value and reverse it? Because we want to be able to create large values, so we should be able to we should be generating values somewhere. Does that make sense?
Yes, makes sense. But again, it was a bit difficult to come up with.
Okay.
By the way, do we need to add another step when we're reversing? Is it
Yes,
fine
please.
if you?
I mean, if you do not add another step, then like 11,3 and 3,11 will be equal, right? And
Yeah.
I don't know if you can generate enough things with it. Let's just think for a second. Yeah, okay. If you're not,
If you don't reverse, it's the constant function just.
yeah, because of the second condition. It just forces you to be constant almost. Yeah.
No, I didn't get what you said.
I don't know actually. Just a second. Yeah, it might force you to be constant function if you don't increase or reverse it, I think.
Does it?
I mean, here also inherently we are
I
switching.
don't think it does.
Like 3,11 is equal to 3,2 we get, and then we are increasing on reversing. Is the idea, right? It like saying it goes to 2,3 and that's not a reversal does not make much sense. Like how are you going from 3,11 to 2,3? You're saying 3,11 is 3,8, which is 3,5, which is 3,2, and now you're reversing. That's where your 1 is being added, right? 2,3 is again 1,2, which is 1 more than 2,3 is 2,1, which is again 1 more than 1,2. So that's where you're adding the value again. And if you did not add that value, that just means it's constant, no? Because everything eventually ends up at f 1,0. Does that make sense? F of a comma b is f of a comma a. No, we never do that. We say f of a comma b is f of b comma a plus 1. If b greater than a. Just a second. Okay, hi, I'm back. Sorry. Anything else?
I think I got a function in which like f of a comma b equal to f of b comma a.
Okay, do share.
Yeah, I
Like,
mean, I got the same in my solution as well. In fact, it was very similar to this. So like
I
Euclidean
like the values,
algorithm only.
like the
What's it?
values for f of b comma a where b is less than a is same. And like you said, f of a comma b equal to f of b comma a for a greater than b.
Okay, and what are the other conditions?
Like this is a function. Like it's very similar, but like for a greater than b, you don't add the extra one. So
No, what's the no what? Okay, what's the function?
Like f of a comma b when a is less than b is the same as what this function says, but for f of a comma b where a is greater than b, we define it as f of b comma a.
I don't quite follow. Can you?
Shall I tell mine?
Yeah. Do go on. Yes, you were telling the solution, right? Please go on.
Yeah. So my solution goes like this. F of a comma b would be the number of steps that Euclidean algorithm or long division algorithm takes to terminate. So you start with whichever one is bigger. So order doesn't matter here. F of a comma b equal to b comma a. Whichever one is bigger, you start dividing that with the smaller one, and then you continue.
Right.
Yeah. So that's how I did, and I think I got satisfied all the conditions as well.
Yeah, I think yours is the one I picked the long division word from. But inherently,
Yeah.
your solution is doing the same thing, right? Like both of what you're saying, when you're applying the long division algorithm, when you're doing the reversal, or like when you're applying the algorithm in general, that's kind of saying that you're reversing. It does not necessarily do it for all cases, but it's still a part of it.
I didn't quite get you.
No, I mean the functions are quite similar in essence, right?
Yeah.
Other than that, you're doing slightly different thing, but that's not very important, I think.
Yeah, I mean it's correct, right? It's not wrong, is it?
Yeah, your solution was completely
okay.
correct.
Okay, thanks.
Okay. So those are the problems, and any comments on them or anything else you want to ask? Oh, Pranjali, you've raised your hand for some reason.
How do you even address that? Okay, it got addressed. That was a mistake.
Okay. Anybody else?
Actually, I was understanding the proof, so now I understood that if the minimum was at t, then it proves the problem for n equal to t.
So yeah.
Yes. So how are there infinitely many such t? Different.
Yeah, that's what you were showing. So consider the difference of the consecutive. Let's say there are finitely many, the maximum of which is n. Okay. Pn.
Yes.
So consider the difference is Pn plus 1 minus Pn minus Pn minus 1, and so on till P2 minus P1. There's a maximum, let's say K, fine?
Yes.
Just, sorry, let's say R. Now just pick your K to be greater than R. So your function will keep on decreasing for the first n value, first till Pn plus 1. So the minima could not have occurred in the first n places.
Okay.
And that's it.
Thank you.
So that's a small thing. Like if one getting in India lecture and one like if he or she reads your PDF, like will be able to follow the solutions.
I think so, but if like you feel like there's some gap in the solution, just put a message on the thread, and I'll try to clear it up.
Like when you say that we vary n from in the P3 solution, 1, 2, 3, 4, and so on till like LK minus 1. So like it is not necessary, you know, that they are strictly decreasing. Right? They can decrease and increase at some point also, but less than the maximum.
Does not matter. It's like the minimum value, right? At some point, we're picking that LK. It may have increased or decreased or whatever, but the minimum was at PLK. So it has to be lesser than the other values.
Oh, okay.
And the minimum, you know why it has to exist, because the function is eventually positive. And initially it's
Yeah.
negative. So as I said before, this is true for any function that grows faster than, which has this property that AK is greater than KR for all large enough K and any real R. And if the inequality was reversed for any real R, AK is less than KR for large enough K, then the reverse thing would be true. For infinitely many n, Pn is less than equal to Pn is 2Pn is greater than equal to PL plus n plus PLK minus. You can just repeat the proof with everything reversed. Is this fine?
Yes, this is fine.
Okay. Any other doubts?
I don't think so.
Okay. Any issues with motivation or something like that, or something of that sort?
What we can learn with this last problem?
I think it's the main target of it was we expected the analytical solution. So we were looking for mathematical the amount of maturity you have.
Oh, okay.
Like how much can you go? How far can you go with such ideas?
Also, I think we didn't expect anyone to actually solve the last question. It was just to see how people attempted.
Yes.
Because the initial solution, it's definitely IMO 3 at least. So
Yeah. The problem is IMO 3.
like the solution is super slick, but it's very hard to come up with.
I think this is much harder to come up with. Much harder to come up with. Let's say this is IMO 6.
Yes.
And it's slightly so that was
where you guys got it?
Pranjal will know that. I don't know.
This is actually very obscure. It was just in a handout somewhere where the source wasn't mentioned, which is one of the reasons we chose it, because we should not pick famous questions. Like, I have no clue what the original source is.
Okay. And
one more thing.
Yeah.
Okay, go ahead.
No, go ahead.
Yeah, so like it's pretty irrelevant, but like are there any students who are not accepted also?
Yes, there was some.
Okay.
I'm not sure if I can say no though. Okay. So what can you learn? This is just I think how big the leaps of faith you're able to take on the problem, I think. And P1 was an easy problem that is hard to find. That you'll not be able to Google or something.
Yeah, all the 3 problems were appropriate.
I don't know if there's much more for me to add unless you have some question or
It is not relevant to the solution of P2, but like if we draw the like graph of f of x comma y, like z equal to f of x comma y if we set, and visualize it in 3D plane. Do you have any idea like how will it look like or something?
None at all. Not even thought about it.
Would it be interesting to think of like maybe?
I don't think so. I think it will be fairly random. Maybe it has something to tell us, but I highly doubt it. I think like it will not give rise to something very special.
I
But,
did that and it's very funny but not useful.
You coded it up and drew a graph.
No. I drew a graph.
How did you draw a 3D graph?
I mean, you can draw 3D things.
Yeah, but it okay. Hard to visualize, no?
I think it would be like kind of for a specific x, y would be like a z and y would be like a step function with the x as the step length, I guess. Something like that.
I don't know
It will
honestly.
be periodic. I don't think it will be step.
Yeah, it will be. It cannot be step, no.
Yeah.
No, like if you were to
Periodic
fix
is fine.
f of x comma y, if you were to fix x and then keep increasing y, I mean for my function at least, it'll after each x one step will increase, right?
Okay, and for those who are actually interested in looking at it, I think some at least one of you would be somebody in the server would be good at like Python and all, and I can think they can just easily plot it with. This is not a very hard algorithm to implement.
I
So,
can try doing that today if I get enough time.
okay, cool. You can
Unless
do
it needs some library I don't have or something.
that. Doubt it. I think PyPlot or something like that should work enough, I guess. Okay, anyhow. I think I mean, maybe not PyPlot, but I think some are there which you can easily create 3D graphs using. Okay, anything else?
Was P1 original?
No, it's from some code forces thing. Pranjal can share the link, I think.
Okay.
I actually can't because I don't remember which contest it is from.
Okay, then I don't know if it's very necessary even.
Yeah, like we picked obscure problems on purpose, so of course they're hard to find good links to. The second question, I think it will be easy to find a link to.
Yeah.
It's already on EOPS.
Okay, sorry. Very sorry for this. Who? Somebody wants live transcription? No, sorry, not doing this again.
Okay, wait, someone sent me the link to
Yeah.
the first problem.
Somebody sent it to me.
Some, yeah, I guess. Okay, yeah, you shared it.
Yeah, okay. People are fast at this, honestly. I'm not just very fast at this.
Yeah, I have something to ask, not for this respect to this session, but for the next session, like is there something that we can have a read so that we can understand better?
What? I didn't quite get your query. Your voice was quite muffled.
So it's better now?
Slightly, yeah.
Okay, so I was asking that, like, not for this session, but the next session, which is like at 8, I think. So, like, is there something which we can read to understand better?
Pranjal, this is for you. Is there any prerequisites or something they should read before the lecture?
Not
No,
like
I'll.
prerequisites, but like something we can read to understand more better.
I mean, as long as you know that there are infinitely many primes, it should be good enough.
And for
that's
the
fine.
and for those who do not know, there are infinitely many
Many
primes.
primes, then definitely look at that.
Let's say there are finitely many primes p1 to pn. Consider the product p1, p2, pn plus 1. You'll find that there must be more primes.
Yeah.
Is there any other problem where this idea is used?
Which idea?
This one, like this infinitude of primes.
Infinitude of primes? Almost
Yeah,
everywhere.
lots of places. Lots of places. A lot of
Then-
times you want to pick a arbitrarily large prime. A lot of
Yes.
times you even do this for like primes dividing a polynomial.
Yeah.
It comes up quite a bit.
Just I was looking for like for some problems to use this. Like if you recall something.
I mean the at or
I mean, honestly, I was planning to maybe give one or two questions which ask for much stronger things after my talks. So,
yeah. In fact, you can go
like,
like very strong. I'll not know how Pranjal is going to, but like for any polynomial p, there are infinitely many primes among p of p1, p of 1, p of 2, p of n, and so on that divide this sequence. In fact,
Oh,
for p, if you take the set of primes that take for any polynomial, let's say sp, and then you take it for another polynomial sq, then even sp and sq overlap in infinitely many primes.
oh,
Okay.
And even you can even say there's a polynomial which has a subset of those primes as its set of primes. I think, yeah. Pretty sure, yeah. You can do that, yeah.
Okay, fine.
Okay, Pranjal, you were saying something. Sorry for interrupting.
no, I wasn't. Also, just to confirm, next, the thing is actually from exactly 8. So the same thing with the opening ceremony won't happen where people are waiting from 30 minutes in advance. So, it'll start basically exactly at 8, just confirm.
Yeah, okay.
so we leave.
Yeah, you can leave.
Okay.
And I hope you enjoyed the application problems.
Yeah, very much.
Yeah, do
Thank
share
you.
the handle.
Thank you.
For joining.
Yeah, do share this PDF.
I think it's already on YouTube since it was live streaming.
No, this PDF.
PDF file. Yeah, I'll just share it right now. Okay, I can end the meeting actually. Bye.